Hi, my name is Ken Lee and I teach computer science at Luther College. In this video I'm going to introduce you to GUI programming in Python using a library called Tkinter. GUI stands for Graphical User Interface, and it does not mean something that's sticky as we might think normally with GUI. It's GUI, Graphical User Interface Programming. Graphical user interfaces respond to events that happen, and so some people call this event-driven programming as well, because we are going to write code that is going to respond to events that occur in our program. To get started with this, we first of all have to import the Tkinter module so that we can use it, and to do that it's just import Tkinter into our program, and we'll have Tkinter imported. I'm also going to do some turtle graphics along with Tkinter, so I'm going to import turtle as well. Okay, so I get those two modules imported, and then I'm ready to start writing my functions, and I'm going to write a def main in this case as one of my first functions, and in fact my main function that I'm going to be working with. And I want to create a window, because GUI programming is all about creating a window on the screen and then writing the code that is going to form that window, the contents of that window, and then responding to events from that window as well. So everything starts with the window. And to create a window in TK, we're just going to start with, we're going to call it the root window, and it's going to be it's from the Tkinter module, and there's a function called tk that will go ahead and create a window for us. Now, before I go any further, I'm actually going to add one more line of code, because a GUI program or an event-driven program needs to listen for events, and the way we get our program to listen for events is to call the tkinter.main loop function. So that main loop function is what listens, what tells Tkinter to start listening for events, and we need to call that because there are lots of events that occur in our program. I'm also going to write the two lines of code that call main. So if name underscore underscore name underscore underscore equals underscore underscore main underscore underscore, then I'm going to go ahead and call main. And I'm going to run this right away so I can see what this program does, and up pops a little window on the screen. That's my root window that I just created there. So with just a couple lines of code here, a few lines of code, I was able to create a window on the screen, and it doesn't do much right now, but it's still a window. Okay. Well, I'm going to work on creating a drawing application for this example. And to create a drawing application, I'm going to want to create an area that I can draw in, and that's going to involve some turtle graphics as well. So the first thing I'm going to do is I'm going to create a widget in my program. A widget is a kind of a fun name to say, but a widget is an element of a GUI program. It's something that we can sometimes see and sometimes we cannot see, but it's part of a window. And in this case, I'm going to create a canvas. I'm going to call that canvas CV, and I'm going to let that, I'm going to create it by, again, saying the name Tkinter, and then calling the canvas constructor to get a canvas created here. Anytime we create a widget, we say where that widget is going to end up. It's going to end up in the root window. In this case, I'm going to make its width. So I have a named parameter here called width, and I'm going to set that to 600, and I'm going to set the height to 600 as well. Just creating an area that I can that I'm going to be able to draw on eventually. Okay, so when I've created the widget, after I've created it, I need to go ahead and place it somehow in the root window, in its container widget that I have here, in this case the root window. And there are different ways I can place it in there, and one of those ways is called packing. So in Tkinter, this is really called layout, and in Tkinter, one of the ways we can control the layout is through packing. So I'm going to say cv.pack to pack this thing in, and I have another named parameter in this case, side equals, and in this case I'm going to put it on the left side, so it's Tkinter. There's a constant called left in the Tkinter module that I'm going to provide to tell where to pack it at. Once I've done that, if I go ahead and run this program at this point, I get my window. You can see it's much bigger now, and I've put I've made a canvas, so virtually the whole area in here is the canvas right now. I'm also going to change the title of my root window because I don't like TK as my title, so I'm going to send a mutator method to the root window, and I'm going to change the title to, in this case, I'm going to change it to draw. So if I run this again, I can see that sure enough the title of it is draw now with an exclamation point. So I've done a couple of things already. After doing that, I am going to set my, I'm going to go ahead and create a turtle. Now, creating a turtle usually involves my saying something like t equals turtle or turtle.turtle. But in this case, I'm going to create a raw turtle because I want to use the canvas that I have just created as my turtle's canvas. Normally the turtle creates its own canvas, but in this case, my raw turtle is going to use that canvas. So I'm going to say t equals, and then it's going to be turtle dot raw turtle, because it's a raw turtle that I'm creating, and I have to specify which canvas it's going to use, and so it's going to use that CV. Again, raw turtles don't create their own canvas, so I have to provide that to my program. I'm going to get the screen object from that turtle. So screen equals t.getScreen, and I can do anything that I've done before. I could set the world coordinates, for example. Don't know why I want to do this in this case, but nevertheless I'm going to do it. Coordinates, and I'm just going to say 0, 0 and 600, 600 are my world coordinates here. So again, if I run this, and whoops, I made a mistake there. It should be set world coordinates. We'll restart it here, and so when I run it, I've still got my canvas here, and I've got my turtle that's been created, and it's going to it's not appearing on the screen at the moment, but nevertheless it's there. Okay, so I want to be able to draw things within this, but I am going to create on the side of this. I'd like to be able to create some buttons to go along with being able to draw, and so I'm going to create another widget at this point called a frame. So my frame widget is created by saying tkinter.frame, and again you specify where it goes, which it's going to go in the root window in this case, and then I need to pack it. So frame.pack, and I can specify the side equals tkinter.right. And in this case I want it to stretch out, so I'm going to say fill equals tkinter.both. So it fills up both sides, fills left and right. That's what that means. We'll see what that means here in just a little bit. And there are various other things I could do, I guess, at this point, but I think what I would like to do next is create a quit button. So I'm going to create a button, quit button, and that's going to be a tkinter.button, and you specify again which widget it goes in. In this case it's going to go inside the frame, and its text is equal to quit, and it's going to call some event handler. So this is going to be our first event handler that we're going to write. And an event handler is a function that takes care of doing whatever it is that needs to be done, in this case quitting the program. So I'm going to call this the quit handler that it's going to go ahead and call, and I've got to write that function. And I'm going to actually write it right above where I defined, where I created the quit button. So normally I would not put functions within functions, but this is one case where that makes sense, and I'll show you why here in just a second. So I'm going to write quit handler. There are no parameters to it, and this program is just going to exit. So I'm going to do a sys.exit 0 to get out of it. And I think to do that, then I'm going to have to import sys at the top. Okay, so let's give this a shot and see what it does first. Oops, and I forgot to pack my button. So I do need to pack that so it shows up. Quit button.pack. And I don't need to say anything to pack, just pack it into that frame. I run it, and there's my quit button on the right hand side. Now when I press quit, it exits. Everything seems to be fine, and it actually called my quit handler here. We can verify that that's the case because we could print something, for example, so we can see that it did call that function there when we ran it. So I click quit. It says goodbye to the screen. It called that code, and I have my first event handler in my GUI program. So let's look again at how this works. I created this quit button, and I said to place it in the frame, which was on the right hand side of the window. I put the frame on the right hand side, and I told it to fill both ways. And this right here, this command equals quit handler, says to go ahead and call the quit handler anytime the button is pressed. So I'm not calling quit handler right here. If I were calling it, I would put left parent, right parent after it. But I'm not calling that function. I'm just simply telling the button, when you're pressed, call the quit handler. And this is what event-driven programming is all about. When an event occurs, do something, in this case call the quit handler. So we'll go ahead and we packed that, and the quit handler does a sys.exit of 0, which just ends the program immediately at that point. Okay, so I'd like to be able to draw something on the screen, and so next I'm going to install an event handler that is going to respond to mouse clicks on the screen. So to find out how to do that, I go to the back of the book, my textbook that I've got, and I go ahead and I look through this documentation, or you can find the same documentation online in Turtle Graphics documentation. And I look at turtle screen methods, and one of the turtle screen methods is onClick. And it says it responds to a mouse click on a canvas. And that's exactly what I'm going to do. I'm going to click on the canvas, so I want to install a mouse click handler for the canvas. So to do that, I'm going to define a function, my click handler, and it's given an X and a Y coordinate, and I want to tell it to tell the turtle, to go to that XY coordinate, and I have to install a handler now, install this as an event handler, and the way to do that is to say screen.onClick, and when there is a click, I want to call the click handler. So if I go and run this here and give it a shot, and if I click, every time I click, I am drawing. You notice here, if I click over here, you can't see the line, but there is a vertical line going down here. So if I click over here, I'm not getting anything, but if I click there, I can kind of work my way up to the edge here, but no further. So now you can kind of see where the edge is at there. So every time I click, I can go ahead and draw another line. So that's great. There are many other things I can do with this program as well. Perhaps I want to be able to do some freehand drawing. If I want to do some freehand drawing, then I'm going to have to drag the turtle around the screen to do the freehand drawing. And again, if I go and I look at documentation about turtle graphics, or if I look in the back of my book, I find a section on turtles and what I can do with turtles. And one thing I can do with a turtle is I can drag it around. So go back to page about 211 here, and there is an on drag for a turtle. So I'm going to create a drag handler. And again, it's given an x and a y coordinate, and I'm just going to do a t.goTo of x comma y. And this time I'm telling the turtle something, so it's going to be t.onDrag, call the drag handler. And actually, I probably could have just called the click handler because they do exactly the same thing. So I'll leave them separate in case I want to change something more later. I go ahead and run this. There's my turtle. I can draw around the screen here. You can see that I wasn't quite keeping up with it. Now I've got an error. It says fatal error. Python quit unexpectedly. There was a stack overflow. I'm going to show you how to fix that right away now. The problem is that Python was not able to keep up with my dragging around the screen, and this drag handler kept getting called over and over again from within itself, and eventually the runtime stack overflowed. So we're going to fix that by changing the way the updates are done to the screen. And to do that, we're going to do a screen.tracer of 0 in our program, and then inside of our event handlers we're going to go ahead and update the screen anytime we've done an update to it. So by us telling the screen to update, we prevent many of the updates that Turtle Graphics was trying to decide to do on its own. So we'll go ahead and just do those updates manually each time, and we won't notice anything except that our program will be more responsive. So as I click, I get my lines right away. When I go to drag this around, I can drag freehand and draw as much as I want, and it just doesn't seem to have any problems whatsoever. Seems to be working just fine here as long as I keep dragging around. So I've got a program now that's got a quit button. It's got a click handler and a drag handler to handle drawing on the screen. Maybe I want to be able to do an entry box as well, and that's something that's interesting to look at as well, to figure out how to enter some kind of a value. Maybe I'd like to write some text on the screen. Let's pretend that I would like to write some text. If I'm going to do that, I'm going to add to my widgets here, and it doesn't matter exactly where I do it. I guess I can do it here. Typically, I suppose I would probably do all my widgets towards the top here of the main program. So we'll start here, I guess, and we're going to create an entry object. Let's call it our text entry object, and that's going to be equal to tkinter.entry, and that's going to go in the frame. And the next thing I have to do is what's called a text variable, and a text variable is used by an entry object to get and set the contents of that entry object, the contents of what's typed inside of it. So we'll say that the text variable is equal to our text var, we'll just create a text var then right before this. So we'll say text var is equal to, and this is called a string var. So it's tkinter.string var that I'm creating here. Now I can set the contents to whatever I want initially. So text var.set, I can say, for example, hello world, and I can put something in there. Still got to pack this entry, so I'm going to say text entry.pack, and and that will make it show up with that text that's in there. Let's just take a look. And so there's my text. I don't like that it just says hello world right now. I'd like for there to be a label above it. So before this, I'm going to go ahead and create a text label, which is going to be equal to a tkinter.label, and I can specify whatever text I want. I first of all have to specify the widget it goes in. It goes in the frame, and then the text is going to be text to write, I guess is what I'll say for the text. I've got to pack that as well, textlab.pack, so that packs it in there. And I think I'm going to go ahead and create one more button now to go ahead and write that text to the screen. I'm just going to copy the quit handler code here. I'm going to go ahead and paste that in here. We'll call this the write handler. And instead of doing this, we're going to go ahead and tell the turtle to write the text that we get from that text var. We have to call the get method on it to write that out. We'll call this the write button then. And we'll have it write the text, so we'll say write text. Instead of calling quit handler, we'll have it call the write handler, and instead of packing the quit button, we'll pack the write button. Okay, so if we've done everything correctly, of course I have not, and that's because of the text here. I needed to say text equals, because that's a named parameter there. Text equals text to write. Okay, so we'll run this one more time. And there I've got text to write, and I've got hello world, and if I click there and click write text, there's hello world being printed to the screen. And I could certainly do lots of other things with this as well. So we have basic elements here for a GUI program. We've got a canvas that we can write on. We've got a frame over here for holding some other widgets. We've got a quit button, a label, an entry box. We've got another button here that can be called to write the text that's in the box out. This entry box, I can enter whatever I want into it, so if I want to write Kent Lee to the screen, I certainly can. And I can click the quit button to go ahead and quit the program. There are lots of different kinds of widgets that we can use in a Tkinter program. This is documentation for Python's version 3.23 and the Tkinter module that comes along with it. You can see many of the different kinds of widgets. There are scrollable widgets. There are other kinds of widgets that we might look at: a notebook, a progress bar, a separator, a tree view. There are lots of different kinds of widgets, and here's a listing of Tix widgets. Tix is another set of widgets that are available for extension widgets for TCL/TK or Tkinter. So lots of things, lots of documentation available, lots of things that can be read about this, and you've seen a few of the different kinds of widgets here in this video.